To solve exponential and logarithmic equations, it is really necessary that we be familiar with the properties of logarithms and exponents very well. First thing I can do to this expression is I can rewrite e to the 2 log x as e to the log x quantity squared equals 0.25. I'm using a property of exponents. Notice if we work backwards, to raise a power to a power, we multiply exponents, and we would get 2 log x as the new exponent. Well, now a property of logarithms says that e to the ln of x means log base e of x, is the same as just x. So x squared equals 0.25. If we take the square root of both sides, we get x equals 0.5. Technically, to solve this step, we would get x equals plus or minus 0.5. But since we're dealing with the logarithm of x, I know that x has to be a positive number. So the solution is x equals 0.5. Well, what happens if you didn't notice this maybe subtle looking trick? Well, another step, another process would be to take the logarithm of both sides of this equation. I can change this exponential statement to a logarithmic statement. So if I take the natural log of e to the 2 times the natural log of x, that must be equal to the natural log of 0.25. If I simplify this expression, the natural log of e to any power is just that power. 2 times the natural log of x equals the natural log of 0.25. If I divide both sides by 2, the natural log of x equals 1/2 the natural log of 0.25, or natural log of x is the natural log of 0.25 to the 1/2 power. I'm using the property that says if I have a number times the log of anything, that's the same as the logarithm of that number raised to that power. Well, a little bit of decimal arithmetic tells me that this is the natural log of 0.5. So, if the natural log of x is the natural log of 0.5, then x must be 0.5. One thing to realize here is that in order to do anything in this problem, it is very necessary that we be very comfortable with the properties of logarithms, the properties of exponents, and the way those two properties relate to one another.